Hey everyone, welcome back to the channel. In today's video, we're going to walk through a full deployment of a web server integrated with a SQL database right here on Google Cloud Platform. I've designed this session to be very hands-on. We're going to start by focusing on Cloud SQL. I'll show you exactly how to get your instance up and running, plus the critical steps for creating backups and performing a database restore if things ever go sideways. But we're not stopping at the data. I'm also going to demonstrate the infrastructure side, specifically how to take a snapshot of your running web server and the exact process to restore it from that snapshot, whether you're building for production or just labbing things out. These are the disaster recovery skills you need. We'll break this demo into four simple phases. First, we'll set up our project and networking foundation. Second, we'll deploy a high availability SQL server. Third, we'll spin up the web server to test our end-to-end connectivity. Finally, we'll walk through the full backup and restore process for both the database and the server. Anyways, I am Anthony De Los Santos, a CCNP certified network engineer, specialized in multi-cloud architecture, leveraging my certifications in AWS, Azure, and GCP in building integrated, secure, scalable cloud infrastructure. Let's take a closer look at our architectural design. As shown in your screen, we've built this environment within the Middle East Central 1 Doha region to ensure our public services and private data are strictly separated. Everything is organized inside a VPC called Demo-VPC, which is divided into three functional subnets. First, we have our public subnet. This acts as the entry point for users and hosts our compute engine web server. For this build, we're using a Debian Ubuntu instance running a Python Flask application. Behind the scenes, we've secured our data layer across two private zones. Private subnet A houses our primary cloud SQL instance in Middle East Central 1A, while private subnet P in Middle East Central 1B holds the standby instance. These are linked via synchronous replication, ensuring that even if an entire zone goes down, our employee database remains highly available and consistent. Finally, we've layered in our protection systems. We're using firewall rules to restrict access to essential web and management traffic. For disaster recovery, we've enabled automated cloud SQL backups with point in time restore, along with machine images to ensure we can restore the web server and its configuration at a moment's notice. It's a robust, layered approach that balances performance with high reliability. To begin, we need to establish our environment. Navigate to the top left of your console, click the project selector, and select New Project. Name this project employee-demo-lab and click Create. Once the project is created, make sure you select the project. Once the project is active, open the search bar and search for Compute Engine API, then enable it. Then search again for Cloud SQL Admin API, enable it also. With our services ready, return to the main menu, go to VPC Network and click Create VPC Network. Name it Demo-VPC and do the same in description. Then let's begin adding your three subnets. First, create our first subnet. Name it as Public Subnet and select Middle East Central 1, Doha region, with the IP range of 10.0.1.0/24. Second, create another subnet and name it Private Subnet A and select Middle East Central 1, Doha region, with the IP range of 10.0.2.0/24. And finally, create another subnet and name it Private Subnet B and select Middle East Central 1 Doha region with the IP range of 10.0.3.0/24. Then click Create. Let's create a firewall policy. Search for firewall, then click on Create Firewall Rule. Name it as Allow HTTP SSH, and for description will be the same. For network, select Demo VPC. It is ingress, and the action is allow. For source IP range, write 0.0.0.0/0. For the protocol, write 80 for HTTP and 22 for SSH. Now, let's start to deploy our Cloud SQL. From the console, search for Cloud SQL, click on it and click the Create Instance, select New Instance. Then choose MySQL, then select Enterprise. We need to select Enterprise so that the high availability features are included. For the preset, select Sandbox, since this is demo only, and to avoid expenses. For database version, choose MySQL 8. For instance, ID. Name it as EmployeeDB. This is the name of your database. And for password, I have already created in Notepad. I will just paste on it. For region and zonal availability, I will choose Middle East Central 1 Doha and select the multiple zone. This is needed for high availability. Then click Specify Zone. For primary database location, choose Middle East Central 1A, and for secondary, select Middle East Center 1B. For the machine configuration, I will choose General Purpose Shared Core to reduce my billing cost. For connection, we will allow the public IP so that we can access the database fast. For network configuration, open it and name it as Demo Access. And the IP range 0.0.0.0/0. I allow public IP and 0.0.0.0/0 because I do this for testing only, but for real scenario, it should be in private. In production, we use load balancer and firewall, but for this lab to make it faster deployment, I will allow these settings. I will check the I acknowledge. Let's go to data protection. I will select the time that is near to my current time so that I will create a backup as soon as possible. For where to store my backup, I will choose multi-region and leave as default location. For the instance deletion options, I will uncheck for the meantime the prevent instance deletion and retain backup after instance deletion so that when I finish this lab, it's easy to delete the database. For days of retention, I leave as default. Then create instance. Next, since the SQL server is already created, I will create my database structure using Cloud Shell. I will enter to my SQL server CLI. Click on it and wait until it will launch and show the MySQL prompt. Using the Cloud Shell, I will activate the SQL admin API using CLI. I will paste the command. Then I will launch another command. This command used to establish a secure remote shell connection to my Cloud SQL instance employee DB so I can execute manual SQL queries. It will ask a password. I will enter the password, the one I create during SQL server creation. I will paste it. Then let's create a database. I already created the database script as shown in my screen. What I will do is just copy and paste it at the CLI. Now, as you can see, my database has been created successfully with one data inside of it. Now, let's create a server for our front-end website. From the console search for Compute Engine, then launch a new instance. Name it Web Server. For region, select Middle East Central Doha. For the zone, I will choose Middle East Center A. For the OS, I will use Linux Server with Debian operating system. Let's configure the network tags. Add tag and write Web Server. For hostname, I will name it as webserverdemo.com. For network interface NIC 0, choose Demo VPC. For network and for subnet, I will choose my public subnet. I will ensure the external IPv4 address. That ephemeral is selected so that we have public IP address that can be accessed by the user from tier PC. Then click Create. Since my web server is ready, I will create my Python program, logic, and functions inside the Linux web server. To do that, you need to SSH the web server. Click on web server to open, then click SSH. Once inside, paste the command to update the server and install Python. I will paste the command now. Next, I need to install the Flask SQL connector between Python web server and database. I will paste now the command. Then I need to create a Python app. The command is nanoapp.py. Then the Linux window will open. I will paste the whole connector script. As you can see in my screen, this is the script. The script is the main program of my website where is the logic and function is reside. I will just copy and paste before save. I need to find out the public IP of my SQL server so that I can update the connector settings. I will copy this SQL server public IP and update my connection strings, including password of SQL server. Save the file by pressing Ctrl O and Ctrl X to go to CLI. Next, I need to create a directory inside Linux for my web page index.html. I will paste the command, then I will create a file named as index.html, our main web page display. I already prepared the script. I will just copy and paste this. Press Ctrl O to save and Ctrl X to exit. Let's start the web application by sending command sudo python3 app.py. Then let's try to access the website using its public IP. Success! Our web page now is working perfectly. I am now in the last part. I will do 3 tests. First, I will failover the database from primary to secondary. Second, I create a manual backup and restore. And third is to create a snapshot of web server and do a restore as well. To start with, I need to go to my SQL server and click on employee DB. When you open your employee DB on the right side, you will see all the information about your database high availability and where it was currently running. And as of now, you will see it is on Middle East Central 1A. So we will do failover by pressing the failover button and let's wait. Now the failover is finished. As you can see, the location of the database now is in Middle East Central 1B. Now let's create a manual backup of our database. Click on Backups menu on the left and click Create Backup. Give it a name. For the location where to save our backup, I will just leave it as default, then click Create. As you can see currently, we have only one data. Since we already created a backup, I will add 2 more data as our changes to database. Then we will restore our old database. I will be expecting that the data will comes back to one data database. Now the database backup is finished. Let's do the restoration now. Let's go back to backup menu and choose the backup you want to restore. Then select restore. I will choose Middle East Central 1 Doha for my restored database. For the instance ID, I will write employee DB. Then I will select overwrite on existing instance. This means I will erase the current one and replace with old copy. I did this purposely so that we can see the outcome that the database data will show one data only instead of 3. Then click restore. Now let's refresh our web page and I am expecting that the data will become 1. Success! As you can see, it returned to 1 data only. Let's do a backup copy for our web server. To do that, we need to do a snapshot. Click on snapshot on the left menu and click again the create snapshot button. I will give a name as web page without company name. I will do the same for description. For source disk, I will choose web server. For location, select regional, and I will select Middle East Central 1 Doha. Then click Create. Now I will modify the web page by adding a title Employee Management System, XYZ Company. As you can see, I already modified. Now let's do a restore. I expect that the title will be gone once restored is complete. First, we need to stop the VM, then click Edit the VM. On the bottom part, click on Detach Boot Disk, then click again, Attach Boot Disk to load the old snapshot. Select Snapshot tab and select your old snapshot. Name it as Web1 and click Select, then start the VM. Restore is done. Check the public IP again of web server since most of the time it will change. I conclude that the snapshot is successful since you will see the old web page shows up without the title. Thank you so much and have a great day.